चलें जी शुरू करते हैं। इस वीडियो में एक्चुअली आई वाज थिंकिंग टू क्लियर आउट द कंफ्यूजन रिगार्डिंग फी। आप सबको पता होगा कि जब हम बीम की रिइंफोर्स्ड कंक्रीट बीम की एनालिसिस या डिज़ाइन कर रहे होते हैं तो उस वक्त वी मेक श्योर दैट the reduced nominal moment, which is actually the product of phi multiplied by the nominal moment, that product actually has to be greater than or equal to the ultimate moment due to factor load. Now generally we take the value of phi, but does the value of phi has to be always 0.9 or it has to be something else? So what is the actually factor which decides the value of phi? So the answer is it is the strain in steel. But which strain? Strain, there can be multiple layers of reinforcement in a beam. So is it the strain in bottom layer of reinforcement or is it the strain in the second layer of reinforcement? So no, it is not the strain in any layer of the steel. It is actually the strain in bottom layer of reinforcement, which is the factor which decides about the value of phi. So let's take an example here. Now this is a beam which has two layers in the bottom. The bottom layer has actually the 4 bars and the second layer has 2 bars. The distance between the face of the top face of the beam to the centroid of the two reinforcement layers at the bottom is 16.8, or which is the effective depth of the beam. The bottom layer of reinforcement is the distance of 17.5 from the top face of the beam. The beam is 20 inches high and the width of the beam is 12 inches. So now we consider that there is tension in the bottom layer of bottom face of the beam and both the layers of the reinforcement are in tension. So we find out the value of strain in this layer of the reinforcement. Now if that strain is equal to 0.005 or greater than 0.005, the phi value will actually be equal to 0.9. And if it is equal to the strain and yield strain of the steel, which is 0.002, then the phi value will be 0.65. और अगर strain की value 0.002 और 0.005 के बीच में होगी, then we will be using this formula to find out the value of phi. So let's find out the strain in bottom layer of reinforcement by using two similar triangles. Let's say first triangle is over this of the strain diagram. The second triangle is this of the strain diagram. We use the similar triangle concept and we find out the strain in actually the bottom layer of reinforcement, this value. So let's find out. After solving this, we find out that strain in steel is actually 0.0055. Now this formula is actually equal to 0.003 multiplied by d sub t. D sub t is nothing but the distance of the bottom layer of reinforcement from the top face, and c is the depth of the neutral axis, which is this one. Since I have already calculated this value using equilibrium, which is 6.19, so epsilon sub t is equal to 0.005, which is greater than 0.005, and hence the phi value is 0.9. I hope this video has cleared some of your concept.